Right, folks, my project is about diatoms. Here we have an image of zipper diatoms, which are really interesting creatures. They colonize and they have little attachment points that look like a zipper, that's why they call them that. And so the question, basic question is, are there diatoms in the cache? Is there a difference between the upper and lower cache? And it's an interesting project because diatoms are found everywhere. There's over 100,000 species of diatoms. And I am not a taxonomist by any means, or a systematicist in identification of diatoms. So the project was limited with that regard. We focused on the presence and tried to make some analysis of the diversity of the diatoms. So let's take a look. Just a basic information about what we're going to be doing today. We're going to look at their characteristics, move on down to the methodology that was involved to study them, and look at the conclusion and the results. And one of the projects that really I was most excited about with this 2-week experience was going to the scanning electron microscope. It was incredible how easy it is to image these small creatures. Here, these are not from our study, but we have scanning images later that we'll show you. They're very architectural, just amazingly designed. And remember, there's over 100,000 different species. There's circular, there's rectangular, fascinating, but they all have a shell. They have a petri dish type joint, and the shells will pull apart when they replicate and whatnot. They're looking at nanotechnology in the future, how you can make micromotors out of these. It's just absolutely fascinating. So here's just a few more images. And they're beautiful. People have used them to make stained glass, microscopic stained glass images by positioning them. And I kind of am curious how they would do that because they're so small. A few more diagrams. Now, there's a girdle view, which is from the side, and then a valve view, which if you think of your belly button being a valve, or if I was a diatom, you'd be looking at my valve view here. So, anyway, so when we looked at them under the microscope, it was a little bit difficult to determine if they were rectangular. It could have been a centric diatom on its girdle view, and that became not a concern, but if we were trying to identify species, it would make it more complicated and name the species, which that was not our goal. A few more images. It gets fairly technical. Growth, again, they replicate, and then they'll just make the other half after they fall apart. So the research, why do we pick diatoms? They have been used quite a bit in studies throughout the literature. The literature was exhaustive. As I looked more and more at it, it became conflicting with regard to whether or not, first of all, are diatoms sensitive? The original research suggested that diatoms were equally sensitive across the board. So that would be a good indicator, just you didn't have to worry about the species. Later on, we found information that, yes, some are sensitive more so to oxygen concentration or pH or other factors. So I think it's an evolving field, which is getting very complicated. This information here says, we know POF et al., the hydrology, if you change it, we have issues with that. In water quality, so that's a foundational research paper. And then the health and stability of the system can be measured with diatom index. There's many of these, okay? So I'll kind of explain the one I picked. They're certainly sensitive to current velocity, salt concentration, salinity, pH, all that, just like any living creature would be. And this is the one that's kind of, I struggle with. It says intermediate. Okay, so that means some eutrophication. We're going to have a lot of diversity in eutrophied waters. So where's the point when oligotrophic waters or low oxygen, what are the cutoff points? And you know, just the basic design of the study was to look at upper and lower cache. Is there a difference in the diversity? Okay, so this can get very complicated very quickly. We kept it simple for this. Diatoms haven't been adequately studied, so it's a great specimen or species, I suppose, to look at. And the questions are, will the reduced water velocity of the lower Cache River exhibit decreased levels of diatom diversity? We know that when water flows, we have more oxygen concentration. At a certain point, it becomes toxic due to low oxygen levels. And then the second question, will the diversity of diatoms be greater in areas with better water quality? So the reverse. Upper cache, more flow, more diversity. Lower cache, low flow, less diversity. And maybe no diatoms. So the hypothesis statement is this. Simply put, if low water velocity, if the decreased velocity of the water will have decreased diatoms. Cache River. So we picked 3 sites, upper cache, 3 sites, lower cache. I actually did walk into the Post Creek cutoff. I collected a sample there. It was kind of fun. It is a real place. It's just east of Carniac on Highway 169. It's not marked. We need some more signs. And I'd like to see a sign that says Post Creek cutoff, and perhaps a date when it went through. That'd be nice. It would help me. Now this is, to begin, we took surface water samples, and we took samples that were off the rocks. And we've definitely got more diatoms off of those rock samples than the water. So any of the index, the diatom index later that we're going to see, was from the samples that were scraped off the rocks at the bottom of the Cache River, which is about, most sites were 1 meter right off the shoreline. Here's our sites spread. Now if you can't really see the Cache River here, but if you just, I've got an image coming later, it just essentially flows like this. And so here we have the lower cache area and the upper cache of this direction. And I've got a general image later that we can see. 3 sites are above and 3 sites are below the Post Creek cutoff. We collected this data just to help analyze our results, and we'll take a look at those in just a moment. It's important to keep in mind, when we look at the diatoms under the light microscope, what are they diatoms? So the treatment of hydrogen peroxide at 30%, which we administered for 10 hours before we went through and looked at the slides, it ate off most, the organic material. We still had debris in the images, but our assumption is that all bacteria would be destroyed. And so when we're going to look at a few slides here in a minute, you'll see the debris, but you'll also see diatoms on these images. And because the diatoms, the shell is not going to be destroyed by the hydrogen peroxide. And remember, 3% is what we buy at Walmart to clean our ears, so 30% is fairly strong. Okay, so we washed the samples taken from the cache and had to rinse off that hydrogen peroxide. If you put it, if you're going to try this in your classroom and you don't do this rinse, then it's just going to bubble under the slide. You're going to see a bunch of bubbles. You can't really take it, get a good picture. We used, the lab called for 40. We went to a higher magnification just to be able to see better images. And we got the index. Here's just, I'm not going to go through the whole calculation, but when we get a number that's low, 0 would be obviously a very poor water quality based on the index for diatoms. And up closer to a value of 1 would be the best water quality. Fair water quality would be in the middle. Here we have Cache River, Upper Cache River. And so let's take a look. This is the most fun here. Light microscope with 630 power. We have 2 fun little diatoms. I don't know if they're friends or not, but we have one here and one here. And it's amazing. Now, some of them are autotrophic, so they definitely would have chlorophyll. And we can see that the hydrogen peroxide did not destroy the internal compartments on some of these diatoms. And so the autotrophic diatoms, you'll see that chlorophyll. It's really fascinating. There's some really mean looking ones. It's hard to see this one, but I think this is a great picture of a centric diatom here. No chlorophyll is seen. So is it heterotrophic? Perhaps. There are species that are heterotrophic. And here we have, some diatoms will form chain. Remember the zipper type diatoms. Some of the people in the lab, I'm not a specialist of this, but we kind of wonder, is that cyanobacteria? So that's a question, but remember it was treated with hydrogen peroxide, so any bacterium would be destroyed.
Did you see the centric one under that one?
Yeah, actually you're right. There are probably more hiding in there.
I think that is the same thing.
Okay, here, yeah.
I think it's the same thing. That's the valve and that's the...
Yeah, it's really fun. It's fun to watch, take a look at these. And the electron microscope makes it even more fun. Now this is another sample. I didn't, the samples, the better I scrape the rock, the more debris I got. And that was probably the biggest problem I had is how do I scrape rocks? Am I scraping it the same? Should I scrape it for 10 seconds? Should I pick a surface area of this rock and then scrape it just the same amount? And that's hard to do. So I didn't really worry about it. This one, obviously, I scraped really good. Got a lot of gel. There's another one. I'm going to go through quick. I put a lot of slides up. Let's take a look. There's kind of a mean-looking creature there. Some are asymmetrical, which at first I wasn't aware of that, but some are asymmetrical. Here we have two. There's probably a few more hiding in there. Large. I did enlarge this slide, but it was fairly large to begin with. The rest of the images were at 630 power. There's an asymmetrical. So these are, again, out of the different sites, upper and lower. There's a scanning electron image. Now this was fun. High magnification. We centrifuged these samples, so there was a lot of trauma to the shells. We saw almost every one of them that we found on the scanning imaging were partial. They were not intact. This is just higher magnification. I thought that it looks like you're traveling to another planet, and a spaceship has crashed on its surface. and this is actually just in the water, down on the rock. So that microscope was just fantastic. Okay, now here's the general results. I've got some graphs coming up, but I like to see the way the river flows. And so we have the upper cache here, site 1, 2, 3. We've got the H2O velocity. Here it was pretty much stagnant, very, very slow. The meter wouldn't read. We've got 30 meters an hour here, so a little faster, about 190 meters an hour there. So there is a flow. Down here, after the Post Creek cutoff, slow, very slow. Down here, stagnant. Okay? The O2 levels, around 1 almost across the board. We had a 1.4 milligrams per liter here, but not much difference throughout. The diatom index, DI, I need to move the decimal over, so 0.47. Just move it over left 1 for each of these. I forgot to do something there. Anyway, on the graph, it's right. DI 5.6, 5.1, so it's in the middle of the range for pretty much all of them. There was no real high, there was no real low. We saw diatoms, multiple species on every sample. So obviously we need more sites to really make a good comparison there. pH, I kind of ignored it. It didn't look like it changed much. So the diatom index, when we look at it, remember site 1 through 3 is upper cache river, and we have lower cache river 4 through 6. According to the index, we're saying fair water quality. Dissolved O2 levels, there was a little spike in that second sample. I really think that the meter, when I used that meter, I took it and put it in a light, where the sun was coming through to the water, I saw a change on the meter just from the photosynthetic effect. And so I'm really kind of curious about how reliable that is. So the conclusions. With our number of sites, conclusions are generalized. We know there's diatoms in the upper and lower cache, and there's multiple species, so which is kind of different than what I thought. I thought that I would see very few in the lower cache river. And that's kind of what I hoped for, but we saw, so I guess that's good for the lower cache, according to this, because we've got fair enough for water quality. So more sites for future studies. Seek to identify presence or absence of specific species. Probably just go with my study was based on oxygen levels. Just try to go target those. And then other interesting things to consider: the macro invertebrate index. What is that? How does that compare to diatoms? And then also Seine, the river. How many fish do we have there? Acknowledgements. Karen Rizzaglia, definitely. Later, 2 gentlemen are at the Scanning Electron Lab at SIU, and that's George Trifton and Robert Hand.